So now that we have delved into the chain rule, it's about time that we actually apply the chain rule in order to determine the derivatives of different fractional and negative functions, or exponents actually, I should say. And so essentially, I've written the chain rule out over here, if you recall it. And of course, n is just an arbitrary real number. And when we say that n is a real number, that implies it could be negative, it could be rational, and it can be irrational. And so we're going to look at all the different cases. So the first and kind of fundamental rational exponent is going to be the square root of x. So the derivative with respect to x of the square root of x, we can go ahead and rewrite this as the derivative with respect to x of x to the 1/2, right? That just comes from our exponent rules, if you recall. And then what we can go ahead and do is just apply the power rule over here. So we take this 1/2, we make it our coefficient, and then we multiply by x to the 1/2 minus 1. And so 1/2 minus 1, that's just going to be equal to 1/2 minus 2 over 2, which is negative 1/2. So then this is just going to be 1/2 x to the negative 1/2. And then we can go ahead and bring the x to the negative 1/2 down to the denominator so it can become positive. So we get 1 over 2 x to the 1/2. And then we know that x to the 1/2, I don't know why that line is so large. Okay. We know that x to the 1/2 is just the square root of x. So this can be rewritten as 1 over, why are these lines coming out so, okay, 1 over 2 square root of x. And so that right over there would be our final answer in simplified form. We could have left it in this form over here, the initial form that we got, but if we wanted to simplify it a little bit, we could have just done that. And so this is a very important derivative. You can memorize it if you would like, although it is very easy to derive, but with time it will come kind of just like naturally. So let's go ahead and do the same thing, but with the cubed root of x. So we can go ahead and rewrite the cubed root of x to be x to the 1/3. And then when we're taking the derivative, we can just apply the power rule again. So we'll get 1/3 x to the 1/3 minus 1. And we know that 1/3 minus 1 is just 1/3 minus 3/3, which is negative 2/3. So then this will be rewritten as 1/3 x to the negative 2/3. And again, we could just bring the x to the 2/3 down to the denominator. So we'll get 1 over 3x to the 2/3. And then we don't really need to simplify it anymore. So that could be our final answer right over there. Again, you don't need to memorize this. You can always just derive it. It's quite easy to derive. Just think about the power rule and just applying it for fractions. The same exact thing you would do if it was an integer, a positive integer. And then let's go ahead and apply the chain rule, or not the chain rule, the power rule for negative exponents. And so we have the derivative with respect to x of 1 over x, which is just going to be the same thing as the derivative of x to the negative 1, right? Because x to the negative 1 is the same thing as 1 over x. And then again, we just apply the power rule. So we take this negative 1, we bring it down as our coefficient, so we get negative 1 x to the negative 1 minus 1. We know that negative 1 minus 1 is negative 2, so this can be rewritten as negative x to the negative 2. And then we can go ahead and bring the x to the negative 2 down to the denominator, and so we'll get 1 over x squared, and that would be our final answer right over there. And so as you can see, we're just applying the power rule as we would if it was a natural number, if it was a positive integer, for when it's a rational number or when it's a negative number. And then over here we have a negative rational number, and we don't really need to convert it because it's already converted for us. So what we do is we just apply the power rule. We can take this negative 3/2 as our coefficient, and then we would just decrement the exponent by 1. So negative 3/2 minus 1. Negative 3/2 minus 1 is the same thing as negative 3/2 minus 2 over 2, which is just negative 5 over 2. So then this would be negative 3/2 times x to the negative 5/2. Again, if you would like, we can go ahead and rewrite this as negative 3 over 2x to the positive 5/2. But these are essentially the same exact thing, so we don't really need to do that. But if you would like to have a more simplified form, you can go ahead and do that. And so essentially, we can apply the power rule to all real numbers. It's not really exclusive for just positive integers. We can even apply it to irrational numbers. So if I gave you, for example, the derivative with respect to x of, let's say, x to the pi, then we would just do the same exact thing. This would be pi. We would just take this take this exponent and make it the coefficient, and then we get pi x, and we just decrement the exponent by 1, so we get pi x to the pi minus 1. And we don't really need to approximate that. We can just keep it in this form right over here. So essentially, this is always going to hold regardless of what real number you input in the, or as the exponent over here. And so we can use that to derive the derivatives of different functions such as the square root function, the cubed root function, and of course the reciprocal function.